Hello everyone, this is Chengge Li. Today I'm going to present our paper SeeTek, Very Large-Scale Open-Set Logo Recognition with Text-Aware Metric Learning. This is a joint work with my colleagues at Amazon, Istvan, Xiaonan, Ivis, and Sirika. Logo recognition is a well-known problem in computer vision with many practical applications. At Amazon, we want customers to enjoy a trusted environment where they can shop with confidence, and we also want to help brands protect their intellectual property and make sure there are no unrelated trademarks and logos. Previous works in logo recognition have mostly been formulated as closed-set object recognition task. However, closed-set approach doesn't scale up. We need to constantly retrain the model as we introduce new classes. In this work, we formulate the logo recognition system as an open-set retrieval problem. There are typically three steps. First, a class-agnostic universal logo detector will generate regions that potentially contain logos. And secondly, a logo feature embedder will project the proposed regions into learned feature space. And lastly, some nearest neighbor classifier will compare the feature embedding with a pre-collected index and predict the corresponding class brand. Open-set logo recognition allows users to detect logos that are not available during the training stage. In this work, we focus on the embedded part of the pipeline. Logos are highly versatile, with very large intra-class variation and very small inter-class distances. Take these images as an example. A query logo crop on the left looks very similar with the right logo crop visually. Naive metric learning training has poor performances, especially on these visually similar yet textually different logos. In the learned metric space, note the logo crop in the lower right for brand Lichifit. A visual-only embedder will project this crop wrongly nearer to another brand, Infity. Our proposed multimodal SeeTek model architecture is straightforward. We augment the visual embedding branch with another syntax recognition branch to extract texts. Where the text branch is penalized by a CTC loss or a character cross-entropy loss, and the visual branch is penalized by a proxy loss. The latent visual embedding and the text embedding are concatenated together to be compared with the retrieval index. Training the multitask model, though, is not a trivial task. In fact, it's very hard to directly train text recognition from scratch. There are no public datasets that has accurate character ground truth for logo images, and brand names are very noisy labels. Therefore, to ease training with noisy brand names, we first used the synthetic text dataset MJSense, which contains 9 million images covering 90K English words, to pre-train the text branch. And further, we will fine-tune the pre-trained text branch using brand names as weak labels. Here are some syntax prediction results. In order to advance the research in this field and push logo recognition tasks into real large scale, we collected a dataset with 3 million logos cropped from Amazon product catalog images across nearly 8,000 brands, named PL8K. Each brand has potentially different logo variant subfolders, and each logo variant has multiple logo crops. This is by far the largest dataset, not only for logo recognition, but also for metric learning. We hope more research work related with the metric learning, syntax recognition, multimodality fusion, etc. will push the field even further. Here are some qualitative results from the SeeTek model. The query image is shown in the left column. In the middle column, we can see the previous non-text-aware model has wrongly retrieved a visually similar logo crop, but it's actually from a wrong brand. And our result is shown in the right column. Despite the large visual dissimilarity, our proposed text-aware SeeTek model has correctly retrieved the corresponding brand, thanks to the help from text recognition. We have evaluated our model on PL8K dataset on different data splits, as well as on 5 other public datasets. Our SeeTek model has achieved better performances on all of the splits, and especially for text-heavy logos. Thank you for your attention. Please check out our paper and supplementary materials for more details.